Hi, welcome back. In the previous video, we explored JavaScript data types, understanding the difference between strings, numbers, booleans, undefined and null. Now that we know what these types are, the next important question is what happens when different types interact with each other? In real world programming, values don't always come in the format we expect. Sometimes a number is stored as a string, sometimes a boolean is compared with a number. And when this happens, JavaScript doesn't always throw an error. Instead, it automatically converts one type into another. This process is called type coercion. In today's video, we'll break down what type coercion is, the difference between implicit and explicit coercion, and how JavaScript decides which type to convert. By the end of this lesson, you will be able to predict JavaScript's behavior with confidence. Let's begin. So, what is type coercion? Type coercion is when JavaScript automatically converts one data type into another while performing an operation. JavaScript is dynamically typed, meaning JavaScript variables don't have fixed types. Because of this, JavaScript often tries to help by converting values instead of throwing errors. Sometimes this is useful, sometimes it's confusing, and sometimes it's dangerous. So let's see the first one, which is implicit coercion. Implicit coercion is also called like automatic coercion, like it happens automatic. When JavaScript converts your own types for you, JavaScript decides what to convert based on the operator being used. So we'll see the examples. The first one. So this is the first one. Now here, if you observe, the first value is a string. Yeah. And the moment JavaScript sees a string with a plus operator, it switches into string mode. So instead of adding two numbers, it concatenates. So 2 becomes a string and then we get 52 as a result. But this is not a number, it's a string. And the second example, this one. This looks similar, but the operator here is different. The minus operator does not concatenate strings. It forces both values to become numbers. So 5 becomes 5. So string 5 becomes a number 5, and 5 minus 2 gives us 3. And here we are using the plus operator, but there is no string involved. So JavaScript treats this as a numeric operation. So when a string is involved, it tries to concatenate because plus becomes string concatenation instead of addition. Here, because no string is involved, JavaScript treats this as a numeric operation. Now the boolean value is converted into a number. So the value of true is 1 and the value of false is 0. Here again, true becomes 1, 1 plus 1 gives 2. And the last one, now we are using double equals, which allows coercion. First, false converts into a number and that becomes 0. Now we are comparing 0 equal to 0, which is true. So this is all about implicit coercion. Again, it happens automatically. Next, explicit coercion. This is when you convert the type yourself, and this is safer, more predictable. So we'll see the examples. The first one is you are trying to convert a string 5 into a number. Here I'm not letting JavaScript guess, I'm explicitly telling it convert this string into a number. The result is 5 and there is no confusion. This is a number 5 and a string of 10. This forces the number 10 become a string. Now it behaves like text instead of a number. And this one, which is, let's say, boolean of 0 or 1. So when converting to boolean, JavaScript follows truthy falsy values. So 1 is truthy, so this becomes true, and 0 is falsy, and it becomes false. So 1 becomes true. And the next important one, which is the plus operator. This is the most confusing part. The plus operator it has some rules. and this is where the most confusion happens. So what is the rule? If one string, like one value is a string, value is a string, everything becomes a string. So we'll see some examples. Like again, as I told, this prefers string concatenation. So if both are numbers, then it will perform numeric operation. But because the one is a string, it performs string concatenation. So again, one side is a in the first example, one side is a number and the other is a string. The plus operator prefers string concatenation. So the number 5 becomes a string and we get 55. Same rule here, the second example. So once a string is involved, everything becomes a string. So this turns into hello 5. It performs string concatenation. And it doesn't matter how many values are present. If one value is present, everything becomes a string. It does not perform, it does not perform a numeric calculation here and we convert this into 10 and then add 10 to 5, which is a string, and give us what, 510 510. It doesn't work like that. Just because it sees one string, it performs string concatenation and results in 555. Okay, that's how the plus operator works. And we'll see other operators, other math operators. You saw how plus operator works, but we'll also see other math operators. Other math operators force numeric conversion. So unlike plus operator, these operators, they do not concatenate strings, they convert values into numbers. We'll see example. I think you can understand what's happening here if you see the examples. So multiplication can't sorry, this is not multiplication can't work here, and also subtraction and also division. So it converts string 5 into a number 5 and gives 5 minus 2 3. So and this results in 10 because the string 5 converted into a number 5 and 5 times 2 gives us 10. Division also forces numeric conversion. String 10 becomes a number 10 and 10 divided by 2 is 5, right? So this is a special case. Both are strings, and this results in 3, because even though both are strings, they are converted to numbers, right? And the next case, which is double equals and triple equals. Double equals allows coercion and triple equals no coercion. That is one main difference. Actually, that I think that is the only difference. No, we'll talk about them later. For now, look here at the examples. So for the first one is 5 is compared with 5 here. Double equals allows type conversion. So JavaScript converts the string 5 into a number 5. Now 5 equal to 5, which is true. And similarly, if you compare like triple equal to does not allow type coercion. So number 5 will not be equal to a string 5. One is a number and the other is a string, different types, so the result is false. Similarly, in this case, false, you saw on the top, like false is converted to 0 when using double equals. So this is converted to 0, because it allows type coercion and it results in true. Here it does not allow type coercion. So a boolean is a boolean and number is a number, and it gives only true if the types are equal, so it gives false. Null, double equals, undefined, true. This is a special rule. Null only equals undefined when using double equals. It doesn't you cannot even if you try to compare it with any other value, it will give you false. it will only equals to undefined. This is a special case. No other values behaves like this. Okay. Now, truthy falsy values. So try to remember these values, because we have only seven falsy values. So it is not difficult to remember these things, but if you remember these things, it will become very easy. So when JavaScript expects a boolean, it automatically converts values, right? So in conditional statements, any condition you give in an if statement, so this is a conditional statement, this is a conditional block, so any value you give here will be a condition. So if the condition results in true, it will perform the operation. If it results in false, it will not perform the operation. Simple as that. So any condition you give here will result in either a true value or a false value. So we'll try to learn what are true values and what are false values. A false is a falsy value. So if I write here if false conditional, I think you can see here. So false. See how this is not highlighted anymore, because JavaScript, like VS Code, is telling you like if this is false, this condition won't be executed anymore. I think we can see it as, we can print it. So if you print it, nothing is printed to the console because it is a falsy value. Similarly, 0 is falsy, -0 is falsy, and empty string is falsy value, null is falsy, undefined is falsy, and not a number is falsy. What is not a number? So again, we'll see this example. So let's say yes, S here. So the math operator, because of this sign, these two should be converted to a number. Yeah, right? That is what we are expecting. At least these are converted to a number, and perform subtraction and gives you the result. But when JavaScript is trying to convert this to a number, it is unable to convert it because there is no number value to this letter here, this character here. So it results in not a number. So you're trying to perform mathematical operation between something which is not a number. So the result will also be not a number, right? That is NaN. So remember like this, when you are trying to perform an operation and there is type difference or anything between the operators, you are expecting a number but you're not exactly performing operation between two numbers, that's why it will give you not a number, and that is a false value. Everything else is truthy. This everything else is truthy. I'll show you some examples. I'll show you. So if let's write hello here, hello. So as I said, everything else is truthy, right? Sorry. Oh, why not just modify this? Even though this isn't a boolean value, JavaScript expects one here. So it converts the string into a boolean value. So non-empty strings are truthy. So this condition runs. You can see this condition is highlighted. It is more bright now. VS Code is telling you before even compiling it. So because there is something, so empty string, like if there is nothing, no character in the string, it is false value. But you have 5 characters in the string, so it is a truthy value. Like there is something, right? There is something in this string. If you observe closely, not a number is like, I can't give you a result. Nothing. Undefined, nothing. JavaScript is telling you automatically. Null, you are intentionally saying nothing is there. Empty string, nothing. -0 + 0, again nothing. False, not true. So everything else is true. And if 0, again see, 0 is a false value, so this condition does not run. These are truthy and false value. And again, this is an implicit conversion. You are not converting the type here. Whatever the value you give here, it is converting automatically by JavaScript. Now we'll have some weird but important cases. Weird, but important cases. These examples look insane, but they follow some rules. We discuss these examples one by one slowly so that they're clear, because they are, you can get easily confused with these examples. The first one, which is an empty string plus an empty array plus an empty array. What happens here? So the plus operator is used. JavaScript checks for strings. So for every time JavaScript sees a plus operator, it prefers string concatenation. So it checks for a string first. If strings are not there, then it performs numeric operation. So it checks for strings. Arrays are objects, so they must be converted to primitives first. Non-primitive data types must be converted to primitives during type coercion. An empty array converts to an empty string. So if you perform, you can try and console log this here. Right. I'll clear this. Yeah. See, nothing. Empty string. So it performs this on an empty string, and if you can see, I think if they have elements, you can see something. Oh wait, clear. So this is how it converts objects into strings. So internally JavaScript is performing two string conversion on non-primitives. Non-primitives are converting to primitives. So if no elements, it will result in an empty string. If elements, then everything becomes a string. So the in arrays, when we are writing comma is a separator, commas are not considered when we are operating with arrays as arrays. But when we are trying to convert it as into a string, even the commas are also considered as characters, and everything is converted into a string. Yeah. So now here empty array is converted to empty string, plus empty array is again converted to empty string. Now the addition becomes something like empty string plus empty string, which results in empty string. Now the second example, again objects. Array is an object, object is an object. The plus operator triggers conversion. So this is converted to an empty string, and the object becomes this string. Why? Because unlike arrays, this is the JavaScript string representation of its objects. So let's say you have an empty object, still the result will be same. You have something inside the object, still the result is same. This is the only string representation of a JavaScript object, and we'll try to console log this as well. So see. Right. So you see the object this string, and again, even if there is empty object, you'll see the same thing. See the same thing. So doesn't matter. This is the string representation of a JavaScript object. Now, when we are trying to concatenate two strings, what will happen? Both are both are concatenated. So because this is an empty string, only this you will see in the result. So when you're trying to add an empty array and an empty object, this will be the result. See how JavaScript is converting. First, it is converting objects to primitives, and then it is performing concatenation. Here, which is empty array double equals fault. This uses double equals, so coercion is allowed here. Remember, triple equal to does not allow coercion. So first false becomes 0. False, the value of false becomes 0, and array is converted to empty string, and then that empty string becomes 0. Now we are comparing 0 here to 0 here, which is true. I think you understand now how conversion is happening, right? So here again in this example, now there are no strings, so now JavaScript performs numeric addition, right? So true is converted to its number, which is 1, and again this also becomes 1. 1 plus 1 gives true, 2, not true, 2. And the last example, which is null double equals 0. This one trips people up. Null does not convert to 0 because and I also told you, like when you're using double equals to null, all only equals to undefined, right? When no other value you can use it on null, like, and it only equals to undefined. And also itself you can use null here or undefined. These are the only two cases it results in true, otherwise it results in false. So this will result in false. So wait a minute, let me check if I missed any example. Mm, no, I think I covered almost everything. So every weird looking example in JavaScript is following a rule behind. Once you understand how the operation triggers coercion, JavaScript stops feeling random and starts becoming predictable. Now we'll understand these rules. Again, I'll tell you how this conversion is happening. While using press operator plus operator, objects are converted to primitives, and if a string appears, then it tries to perform string concatenation, otherwise numeric addition. Simple. This is about plus operator. All other operators tries to convert them to numbers. And when using double equal to, a boolean is converted to number. Strings are also converted to numbers. Where I showed you one example, I think this is the example. So it was this. So we are using double equal to. This is objects. Objects are committed to objects are converted to primitives. So it will convert to a primitive type, which is string, empty string, and then strings are converted to numbers, right? Which is 0. This is how it becomes 0 equal to 0. And boolean becomes to a number. So where boolean is, we saw in one example, false double equals 0. Yeah, in that example, false become converted to 0, right? And the only special rule is null. When using double equals, null only equals to undefined and itself. Anything else results in false. And how JavaScript is deciding, uh, again, this is like a summary of the basic rules. Converts objects to primitives, plus operator checks for strings, other math operators for numbers. Based on that, they'll perform string concatenation or numeric operation. And double equals converts before comparing, and triple equals no comparison. And when coercion is helpful and when it's dangerous. So it is helpful when during form inputs, everything is a string, uh, and you have no confusion there. Everything is a string. And when you're simple conversions like so, right? I think this is one. So true is true, false is false. True is one and false is true. Something like this. Simple conversions and quick checks. You want to check for a condition, and you want to check for if this value is equals to this value or not. So just like this, I try to console log and show you, right? So similarly, you can check before even passing the condition in an if block. You can check the things you want to pass. So you want to pass a one, and you want to compare it with true. Can I use you have these two values, these two variables in your code, and you want to compare them. During these simple comparisons, type conversion is helpful. When it's dangerous, when you're using double equal to. So this should not result in true. When you're writing, this is not a good practice. But if you use double equal to, it will result in a true. It will result in true, and that's not good. So you should always use triple equals, right? So when you're using double equals, it's dangerous. Type coercion is dangerous, and when you're trying to mix unknown types, so you have two variables, you don't know what is what, and you're trying to perform some operations between them. So when you are performing operations between unknown data types, you'll get unexpected results. Yeah, because JavaScript internally changes types based on the operator. And you're trying to compare user inputs without conversion. That time also it is dangerous. Basically, it gives you bugs and unexpected results. And what are the best practices? Like, I think I already mentioned this. Always use strict equality, because it checks for the value, and at the same time it also checks for the data type. So here this gives false, because even though true is converted to 1, repeat equal to does not allow type coercion, so it stays true. And because the data type is different here, it gives you false. And whenever possible, try to convert types explicitly, like this, like so. Where is this? Here. So try to convert the types explicitly. Like what happens is, like you will know like what you are doing with the variables, and you will know the data types you are dealing with when you're trying to convert the type explicitly. Like if you know it is a string, and you know it is you're trying to add it with a number. So what you'll do is you'll try to convert the type by yourself, and you'll convert it to a number, and you'll then add it. Always try to convert it explicitly when possible, and try to remember your falsy values. Again, only 7 falsy values we have. Everything else is truthy. So remember this, and be careful with plus operator. It always prefers string concatenation to numeric operation. Yeah. So when using when you're dealing with strings, just strings and numbers, just be careful. Remember the rules of plus operator. Okay. Summary: type coercion isn't random. It follows some rules. I try to explain those rules. I hope I'm clear. Once you understand those rules, JavaScript stop being confusing and starts becoming predictable. Today we converted types explicitly, and we saw how implicitly they are converted. So we covered JavaScript type coercion, I guess, and implicit explicit type conversion, operator behavior, equality rules, truthy falsy values, and the weird examples developers often struggle with. If you're still confused about behavior of null and undefined, don't worry, let me know in the comments, and I'll make a dedicated video explaining them clearly. And if you watched my previous video, I think I covered most of it. Still, if you have doubts, if you're confused, let me know in the comments. And in the next video, we'll move on to JavaScript operators and expressions, where we'll start building real logic in our code. And if this helped you, like, subscribe, and share it with someone learning JavaScript, and I'll see you in the next one.